Good morning and welcome to this Room 2003 Science Skill video on the topic of balancing chemical equations. This particular video shares a visual graphic method for balancing chemical equations that may help you if you kind of have a hard time, like myself, just keeping track of the numbers. So with that, let's cover a few do's and don'ts that come to us from the law of conservation of matter, and one suggestion from myself, and then we will get into the two examples of balancing chemical equations. First, a do not that comes to us from the law of conservation of matter is do not change subscripts. When we change subscripts, we change the identity of substances, and we're not allowed to do that. H2O is water. H2O2, a difference of 1 on one subscript, is hydrogen peroxide. So to change that one subscript only by one atom, we change the identity, and we're not allowed to do that according to the law of conservation of matter. The second do not is do not add or remove substances. This would be very nice. It would make balancing equations maybe a little bit easier, but again, we can't do it because if it didn't go into the reaction on the reactant side, it's not allowed to come out on the product side. So do not add or remove substances. The third thing is we do adjust coefficients. When we adjust coefficients, we are not changing the identity or the kinds of substances in the reaction. We are simply adjusting how much. And when we adjust the how much on one side, that is reflected in the how much on the other side. So do adjust coefficients. And the fourth thing is just a tip that I use and remind myself of. When I'm balancing, I try to focus on one element at a time. This is especially helpful when you're in those real thorny equations that just seem like they're never going to balance. When I get into those, I just make sure I look at one element at a time and keep going back and forth until it balances. And it really does help. So if you struggle with those, just stop and focus on one element at a time. All right, with those four things in mind, let's go ahead and get set up on this equation. The first thing I do in this visual graphic method is I divide the equation, reactants on the left and products on the right, and I do that with a line. The line passes through the arrow in the equation because the arrow represents the process, the chemical process. On the left of the arrow are the reactants, and on the right are the products. And those are the sides that have to balance. So the number of atoms of elements on one side have to match the number of atoms of elements on the other side. The second thing I do is represent each substance molecule with a drawing using the element symbols. And it looks something like this. The reason I use the circle is that everything in the circle has to stay together. I can't add something into the circle that's not there, and I can't take it out if it is there. So the circle represents those elements or molecule, and each individual symbol represents the number of atoms of each element represented by the formula. So in titanium tetrachloride, I have one titanium, I have 4 chlorines, 1, 2, 3, 4. So I just simply visually break down the chemical formula to show each individual atom using the element symbol. Once I have this set up, looking across the dividing line, I can see one of the things I see right away is that my hydrogen is out of balance. I have 2 here and 1 here. And that is a fairly straightforward thing to fix simply by adding 1 hydrochloric acid molecule. So now my hydrogen's in balance, but the chlorine is still out. I have 4 here, 2 here, so let's add 2 more hydrochloric acid molecules. Now my chlorines are in balance, again staying with one element at a time, but my hydrogen is not. So I have 4 here, 2 here. I'm going to add another water molecule. So now as I look at this, it looks like I'm balanced. So let me just give it another visual check. It appears to be balanced, so now I'm going to do a little tally at the bottom to check that more specifically. So I've got this little T-chart arranged by element. All I'm going to do is count up the number of titanium element symbols on this side and that side, list the numbers. If all the numbers match, then I'm balanced. So I have 1, 4, 4, 2, titanium, chlorine, hydrogen, oxygen. On the reactant side, let's see what I have on the product side. The numbers of atoms of each element on both sides match, so I'm balanced. The last thing we have to do is to count the number of molecules of each substance. That number becomes our coefficients. We'll put those in the blank and we will be finished. So there we have it. We have the balanced chemical equation complete with the coefficients. And what we did again was we adjusted the amount of each substance, and in doing so we kept the number of atoms of each element on each side of the equation the same. All right, let me pull up example 2 and I'll get this erased and we'll run through it. Okay, I went ahead and put in our dividing line between reactants and products. I also went ahead and sketched in the one molecule for each of the substances. And you have the ammonia with 1 nitrogen and 3 hydrogens, a single molecule. You have the atmospheric oxygen, O2 molecule, nitric oxide, 1 N, 1 O, and the water molecule, 2 H's and 1 O. So one thing that jumps out right away, there are actually a couple things out of balance, but the oxygen jumps out as, no, I'm sorry, the hydrogen. The oxygen right now is balanced. We have 2 and 2, but the hydrogen is out of balance because we have 3 and 2. So what I'm going to do is I'm going to add on the side that's lacking and try to go back and forth until the hydrogen is balanced. So I'm still out of balance. Now I have 4 and 3, so I'm going to add to the lacking side. Six and 4. And now I have 6 and 6 hydrogen atoms on each side. But now for sure my oxygen's out of balance. I have 4 oxygen on this side, 2 on this side. A single O2 molecule takes care of that. Now I have 4 and 4. However, I now have 2 nitrogens and 1. So let's fix that. So the nitrogen and hydrogen's balanced, but I just drove the oxygen out of balance. Now I have 5 and 4. I'm going to add to the deficit side. Now I have 6 and 5. The easiest way to fix that is with 1 O here. So now my oxygen is back in balance, but in Fixing oxygen, I drove the nitrogen out of balance. So let's put in more nitrogen over here. So now my nitrogen and oxygen balance, but I just boogered up the hydrogen. Now I have 9 and 6. So let's add to the deficit side. Ten and 9. So let's add to this side. So I think I said 6 on this side a moment ago, I'm not sure. But anyway, now we have 10 hydrogens on this side, 12 on this side. We're getting close. 2, 4, 6, 8, 10, 12, 3, 6, 9, 12. The hydrogen is balanced. Nitrogen, I'm 1 out. My nitrogen is balanced. Oxygen-wise, 6, 7, 8, 9, 10. I have 10 here, 6 here, 8, 10. I should be balanced. Let's do the little table down below to compare them. And if the number of atoms of each element on each side match, I'm good. Four, 4, 12, 12, 10, 10. I am balanced. Last thing we need to do is count up the number of molecules of each substance, and that becomes our coefficients. That is our finished equation. We are now balanced with the coefficients of 4, 5, 4, 6 in that order. All right, that's all there is to balancing chemical equations, and I hope this graphical method helps you. If it doesn't, please head over to YouTube and see if there are some other methods that will help you get better at and be better at balancing chemical equations. But as we wrap things up here in Room 2003 Science, like we like to say always, be safe and do science.